Hey, welcome. My name is Gulhami. Today we will talk about Digital Speed Controller DSC-1000. This controller is applicable for generators, vehicles, engine as a high-performance ambient control system designed based on a PID control for fast and a precise control of engine speed with an enhanced microcontroller unit that minimizes analog circuit vulnerable to user environments. This controller also has the features of a PID auto setting along with a battery voltage, pickup sensor and actuator checking condition. This controller also has a black box function that manages engine operating record when a fault are detected to user have a more convenience in operating this precise digital speed controller. Now let's have a look on this controller. This controller is made of rigid aluminum case, taking into account anti-shock electromagnetic resistance and environmental protection. It contains graphic LCD and high-performance MCU inside the controller, and a heatsink is located on the outside of the case for protection and a precise control of actuator operating elements. A terminal block is located on the bottom and right of the front side for easy connection to external devices. RS-232 and a CAN communication is available, and a D-Sub-9 connector enable universal use of RS-232 communication. We can easily input and adjust value for parameter input using 8 button keys. In addition, graphic LCD show graphic display, bar graphs and a design symbol so that user can readily identify the control information, while external LED display imported conditions of the engine. For installation of this controller, it should be connected to the pickup sensor attached on the engine and the actuator. Speed trim, droop, idle and auxiliary terminal can be used for additional function. In connection with surrounding circuits, it can be also used to operate external devices using crank, run, hour speed functions. RS-232 and a CAN port allow communication with PCs or external host computers for data transfer and monitoring functions. When it's supplied by the battery, 24-volt DC is connected to the controller E negative and a F positive with the respective polarities of the battery E negative and F positive of the battery negative and the positive. For connection to the actuator, terminal A and terminal B of the actuator regardless of their polarities. One should be 18 AWG or better, and the outside should be wrapped by the plastic tube for insulation or insulated mesh lines. And for connection to the pickup sensor used for know the engine speed and is connected to the terminal C and terminal D that can be receive signals of AC RMS 3 volt or higher. Wire should be twisted or shielded cable connected to the ground together with the terminal D, and a gap between the pickup sensor and the tooth should be at just 0.9 mm and a 1.1 mm. Here you can use crank, run and hour speed contact point during operation when the controller active the function. It can supply power output 10 volt to external devices through P terminal. User can easily use the terminal when external auxiliary devices need a power supply. However, power supply of 20 milliampere or higher should not be used, and care should be given to prevent short circuits. The controller can be configured or operated by input keys according to the menus on the LCD display, selecting one and assigning value in the selected menu to input control information to the system. Input information should immediately apply to the controller system once updated. The controller has 8 input keys including LCD, mode, menu, enter, up, down, left, right keys. LCD key turn on and off the display. Mode keys switch the display to either operation mode or away from display. Menu key, user can change the menu display and go back to the previous menu. Enter key applies designated value on the LCD display to the system. Up key increase the values in the selected menu or go up. And a down key decrease value or go down in the selected menu on the display. And a left key move to the left in the selected menu, and a right key move to the right in the selected menu. When DC 24-volt power is supplied to the battery terminal, E negative and F positive of the controller, the power LED in the front side of the controller turn on in red, and the arrow LED turn on in red where there a false condition. At this moment, the LCD display is not activated and Doosan logo will appear for 1 second, followed by the operation display after pressing LCD button. The controller will start control based on information from pickup sensor and other input devices and designated parameter values. At this moment, where breakdowns of surrounding device or system errors occurs, the LCD display will show such errors and processing messages. When you supply 24-volt DC to the controller, the power LED turn on red. The controller will start to operate with the LCD display off, but after pressing LCD button, the Doosan logo will appear for 1 second as shown below, followed by the controller operation display. Then the LCD display will switch between on and off by pressing LCD button. Here are the indication of a tube, idle, trim auxiliary. Here display date and time. Here display set RPM. Here display operating RPM. This one display the remaining fuel of the actuator. This one display the operation hours while the system is turned on. When you enter to the menu, there are 10 sub-menus: engine type, system setup, PID GAN setup, PID auto setup, date and time, alarm list, actuator test, default setup, system information, LCD setup, system monitor. Here is the first menu, engine type. This menu offers function to configure setting value of the controller depending on the types of engine in advance and apply such preset value to the selected engine. To enter this menu, press enter button. There is a preset value for the engines, and then you can select it by enter and then press menu for back. The second one, system setup. It consists of sub-menus of the system configuration items of the controller, including the one for configuring run, idle, hour speed, crank, gear number, related to the RPM setting. Depending on additional function, user can designate value for starting fuel, speed cramping, actuator, maximum and minimum limits of a low battery. To enter this menu, press enter button, and here is a set run RPM. So we can designate normal speed target RPM of the engine. We can input different normal speed values depending on the specification of the selected engine. For increasing and decreasing this value, press enter and using up and down button to increase and decrease the values, and then press enter button again to save the value. Here is a set idle RPM. We can input value to control the idle operating speed of the engine. To increase or decrease this value, press enter button and then increase and decrease the value and then enter to save this value. There is a set hour speed. We can designate RPM value to activate engine protection functions when the speed exceeds the normal level target RPM and reach the hour speed range that may cause problem to the engine. When the engine RPM reach the hour speed RPM range, the engine immediately stops with the error message and alarm. Here's a cranking RPM. We can designate the RPM value to activate the actuator when the engine starts to operate. Here's a gear number. User can input the number of a flywheel teeth in the engine to the controller so that the controller can calculate the accurate RPM depending on the values of pickup sensor from the engine. Here's the starting fuel. We can designate the amount of a fuel used when the engine starts to operate and the operating current for the controller to activate the actuator change based on these values. Here's the trim enable. You can on and off it for trims, and then you can trim percent set, and then auxiliary enable. You can off and off, on and off for auxiliary. So if you need to apply auxiliary speed, so user can adjust value to ensure safe operation of the engine based on the auxiliary signal values when the auxiliary is enabled. And here is a speed ramping. We can input ratio value of the speed change when the speed increase or decrease the idle condition of engine. Here's a maximum current. User can designate value operating current for the actuator of the engine. Here's a low battery, so you can set the limit of the battery voltage. So you can enter button and increase and decrease the limit of the battery, and then press enter button again. It measures the battery voltage supplied to the controller. When the measure value are lower than the preset voltage values, it will be alarmed using the acceptable battery voltage is between 20 and 22 volt without load. Here's a droop gain. User can designate the droop value applicable to maximum load based on the current consumption of the actuator. Here's a full load current. User can designate the maximum current values when the generator is in full load. Here's a no load current. We can designate the operating current value of the actuator when the generator has no load. Here is the third menu, PID gain setup. What is a PID gain setup? PID is a proportional value, integral and differential value. So enter this menu, enter the button, and then now here user can input proportional, integral and differential value as an input to the PID control of the engines. So user can easily increase and decrease the proportional and then integral and then derivative value, and then press the enter button to save the value, and then press menu button to go back. And then the fourth one, PID auto setup. This menu offers function for automatic designation of the proportional, integral and differential parameter value related to the engine PID control. After starting the engine, select drive unit menu. In the man menu, while the engine has a no load and a PID auto setup menu, press the enter button, and then system message show auto setup mode PID setting, yes or no. If you selected yes, the controller will repeatedly change the RPM to automatically calculate the optimized proportional, integral and derivative values. If the controller identifies the optimized PID values within a 30 cycle, it will display PID auto setup complete. When you press enter, it will apply turn PID values and close the menu. Setup complete. Okay, when you press enter, it will apply tune PID values. If the controller fails to identify the optimized PID value, so no successful. Okay, when you press enter, it will apply the final PID value and close the menu. Here's the fifth one, date time setup. We can designate or set the year, month and a day, hours and minute of the controller, and the designated time will be used to monitor the system and manage fault messages. Here is a alarm list. This menu displays year, month, day, hour and a minute of the errors in the controller and types of the fault in a code which are used in troubleshooting. Here is the alarm code table of a digital speed controller. Whether there is a problem in the system operation, you need to review the alarm list menu of the controller and check the engine and the system in the reference to the alarm code. If the first code is E01, it's a battery low. When the battery voltage continues to be lower than the low battery values or more than 5 seconds. So you can check the battery line or replace the battery. The second code is E02. It's a battery high alarm. When the battery maintains its voltage exceeding 30 volt DC for more than 5 seconds. So for this you can check the battery line or replace the battery also. The third code is E03. It's a pickup error. Problem in a sensor signal when the engine start or engine RPM lower than 600. So for this you can measure or check the RPM sensor and connecting circuit, or you can replace the RPM sensor. Here's a 4-alarm pickup error. It may be happen when a problem in a sensor signal during the engine operation or engine RPM 600 or higher. For this you can check the RPM sensor and connecting circuit, or you can replace the RPM sensor also. It's the fifth one is a E05. It's actuator current open. It happens when a disconnection in the actuator or connecting circuit. So you can check the disconnection in the actuator and connecting circuit, or you can replace the actuator also. The sixth code is a E06. It's actuator current short. That happens when a short circuit in the actuator or the connecting circuit. For this you can check the disconnection in the actuator and the connecting circuit, or you can replace the actuator. The seventh code is E07. It's hour speed when an engine RPM exceeding the configured hour speed value. So you can check the speed setting or adjust PID setting value. If your PID is not auto-tuned or is not a tuned well, so it also happen or it also malfunction like our speed alarm. The eighth code is E08. It's a fat driver error. It's damage to component in the actuator output sessions inside this controller. When the problem described in alarm code E3, 4, 7 or 8 occurs, the engine is not available for a safe operation, or therefore the engine will stop as the controller will turn off the actuator for a safety. When a problem described in alarm code 3, 4, 7 or E8 occurs, the engine will not able to restart as long as the alarm is not released. When alarm occurs, you can release them by turning off the power of the controller. Let's go on our next menu. Here's the actuator test. This menu offers function to test whether there is any problem in operating load current of the actuator attached to the engine. It indicates voltage and current for on and off. Here's the default setup. When you can't identify the type of control engine by the controller, this menu offers the most common parameter setting value. For a default setup, select yes and then press enter button. If you don't want to implement this function, then press no button. If you press yes button, all the configuration value will be changed to the default one of the engines. And the ninth one is system information. Once you enter this menu, the controller displays its information including the serial number, software version, last update date, and alarm count, and the engine runs. Now let's come on the next menu. It's the LCD setup. To enter this menu, press enter button. Here you can adjust LCD brightness, LCD contrast, and a power on LCD, auto LCD off, auto LCD off time. So here you can press enter button to increase and decrease the value. For save the value, press enter button again. For going back, press the menu button. Here's the last menu, system monitor. To enter the menu, press enter button. Here you can see that engine RPM, valve duty. So this menu offers to monitor the controller operation. It shows values for engine RPM, value duty, value current, auxiliary RPM input, pickup voltage, and a battery voltage. So you can check all the things and monitor all the things from here. Thanks for watching this video. Don't forget to subscribe and a thumbs up for more videos.